In this lecture, we find cube root of unity, and hence we also prove that sum of these roots is 0 and product of these roots is 1. So we use de Moivre's theorem over here to find out the cube root of unity. We have to find the cube root of unity. Let x is equal to 1 whole to the power 1 upon 3, because we want to find the cube root of unity. What it means? It means this is the cube root of 1. Cube root of 1. So clearly, if we try to, if we take the cube on both the sides, it is x cube minus 1 equal to 0, which gives us x cube minus 1 equal to 0. So since this is cubic equation, so definitely we get the three roots. So out of these three roots, one root is 1 and the remaining two roots will be in the complex root. So let us try to simplify. So this we are writing x is equal to 1 whole to the power 1 by 3, which implies x is equal to 1 plus I into 0 whole to the power 1 upon 3. Here real part is 1 and imaginary part is 0. Now let us try to find out we want to first convert this complex number which is given in the general form into the form of polar form. So if you want to convert any complex number into its polar form, we write down r equal to r is modulus, which is equal to root over um, x square plus y square. So here x square is equal to 1 and y is 0. So 1 square plus 0 square is root over 1 square means 1, which gives us 1. Similarly, if you want to find out the theta, means argument, then argument is nothing but tan inverse of, since it is in the first quadrant, so we take it tan inverse of 0 upon 1, which gives us tan 0, and the value of tan 0 is again 0. So this x can be written as 1 is the modulus, and then cos of 0 angle plus I sine 0 whole to the power 1 by 3. Now we again know that cos 2k pi plus theta, which is equal to cos theta. So this cos 0 can be also written like this. X is equal to cos 2k pi plus 0 plus I sine 2k pi plus 0 whole to the power 1 upon 3. So now it can be also written like that. X is equal to, because if we add 2k pi plus 0 is 2k pi. So it become cos 2k pi plus I sine 2k pi whole to the power 1 upon 3. Now here we apply the de Moivre's theorem. It is cos theta plus I sine theta whole to the power 1 upon 3. So this 1 upon 3 will be multiplied with the angle. Now this is the de Moivre's theorem. Cos theta plus I sine theta to the power n, which is equal to cos n theta plus I sine n theta, which implies x is equal to cos 2k pi, because this 1 by 3 will multiply with 2k pi, so 2k pi upon 3 plus I sine 2k pi upon 3. But again we know that cos x plus I sine x, which is equal to e to the power ix. So this can be written as cos 2k pi upon 3 plus I sine 2k pi upon 3 can be written as x is equal to e to the power 2k pi upon 3. Now, if we put the value of k equal to 0, 1, 2, we get the different roots of the cubic equation x cube, yeah, rx equal to 1 to the power 1 upon 3. So let us put k equal to 0, 1, 2 in 2, we have x0 equal to k equal to 0 means e to the power 0, e to the power 0 is 1. Similarly, if you put k equal to 1, so e to the power 2 pi I upon 3, 2 pi I upon 3. Let us consider this is omega. Similarly, x2 is equal to, let us put k equal to 2, so this is 2 to the 2 multiplied by 2 pi I upon 3. So it can be written as e to the power 2 pi I upon 3 whole square, and which is omega square. So let us see what will happen if you put k equal to 3. If you put k equal to 3, then this will be this 3 and 3 will cancel. We get e to the power 2 pi I, and e to the power 2 pi I is again uh, e to the power 2 pi I, which gives us cos 2 pi plus I sin 2 pi, which is equal to 0 plus, sorry, cos 0 is 1, 1 plus I 0. What it means? It means value of 1. So if you put k equal to 3, we again get the value which is equivalent to x0. If you put k equal to 4, that should be equal to omega. If you put k equal to 5, we get omega square. If you put again 6, then we have again x0 which is equal to 1. So these values are repeating. So this equation has only 3 roots, right? We know that how many values we can get for the k. So it has infinitely many values, but that values are in the cyclic. It has only, we can only use the 3 roots: k equal to 0, k equal to 1, and k equal to 2. These are the only 3 values. Hence, the cube roots of unity are given by 1 omega and omega square. Now, this is the first part of the question. We have obtained the cube root of unity. Now we have to prove that the sum of product of this root is 1 and sum of this root is 0. Thus, 1 omega omega square are cube roots of unity. Now let us go ahead. The first point. Now, product of cube root of unity is 1. We have to prove this one. So consider the product of 1 into omega square. We have 1 into omega square, which is given by omega cube, and omega is equal to what? It is e to the power 2 pi I upon 3 whole cube. So it can be written as this 3 and 3 will cancel. We have e to the power 2 pi, and e to the power 2 pi is cos 2 pi plus I sin 2 pi, which is equal to 1 plus 0 into I, which is equal to 1. So hence omega cube is equal to 1, means product of this cube root of unity is equal to 1. So this proves that product of cube root of unity is 1. Now, the second case, we have to prove that sum of cube roots of unity is 0. So let us consider the sum of 1 omega and omega square. We have S3 is equal to, we know that the sum of this is what? It is geometric series. So sum of geometric series, or sum of first n terms of geometric series, if it is n, let us see, it is n, then it is a into 1 minus r to the power n multiplied by a into whole multiplied by 1 minus r to the power n whole divided by 1 minus r. Here a is equal to first term, which is 1, r equal to common ratio, means w upon 1, which is equal to w square upon w, which gives us w. So, and n equal to 3, n equal to 3. So therefore we have written over here S3. So S3 is equal to 1 into 1 minus omega cube upon 1 minus omega. But we know that omega cube is equal to 1 from this previous result. So therefore S3 is equal to 1 into 1 minus 1 upon 1 minus omega. So 1 minus 1 is 0. So it gives us sum of these three roots 1 omega omega square, which is equal to 0. So these are the two byproduct of this question. Thank you.